Now that we've begun our study of differential equations, one thing that we're going to be looking at is something that's called slope fields. So we're going to start our slope fields investigation with an exploration. So at the end of this lesson, you'll be able to see how a slope field is related to the solution of a differential equation. Directions on this exploration say to graph the family of functions that solve the differential equation dy dx is equal to the cosine of x. So this is something that we should be familiar with. We've been separating variables, so we could easily do that. But what I'd like you to do is to see what happens when we do something that's called the slope field. So what we're going to do is find each of these things, and then we'll just see how a slope field is connected. So the first thing it says, I'm going to go ahead and draw a graph. So we've got something, we know we've got something to do with the cosine. Oh my word, sorry about that. I'm going to put pi over 2, pi, 3 pi over 2, and 2 pi, and then I'll go the other way as well. Negative pi over 2, negative pi, negative 3/2 pi, and negative 2 pi. And then on my y-axis I'll put 1, 2, actually I'll just have it go up to 1, because really, so we'll have this be 1 and this be negative 1. Okay, so now we've got the graph. So the first one, it says to find dy dx equals cosine of x at the point negative 2 pi 0. So what this is asking me to find, dy dx, please remember, is just another way of saying the slope. So we want to find the slope of cosine x at the value negative 2 pi and 0. And remember that negative 2 pi is our x value, 0 is our y value. So at that point, we would like to know the slope. So what we're going to do to find that slope, our dy dx will equal the cosine of negative 2 pi. All right, and if you find the negative 2 pi on a unit circle, here's my unit circle, negative 2 pi would just be going clockwise instead of counterclockwise, so 2 pi is still going to be right there. The x value there is 1, so that slope is 1. Right, dy dx of cosine x at negative 3/2 pi 0, we're going to be again finding the slope. And so that would be cosine of negative 3/2 pi. That would be going clockwise around 1.5 pi, which would be up here. The cosine up there would be 0. Then finding dy dx equals cosine x at negative pi 0, we're going to get dy dx is equal to the cosine of negative pi. And cosine of negative pi is just over right here. That cosine, that x value is negative 1. And then dy dx equals cosine x at negative pi over 2, 0. Again, dy dx is just my slope, so my slope is going to be cosine of negative pi over 2. And cosine of negative pi over 2 is just stopping right here at that first pi over 2. And my cosine down there will also be 0. So now what we're going to do is actually put these values onto my lovely graph up there. So we found out that the slope of cosine of x at the point negative 2 pi 0, the point negative 2 pi 0 is right here. The slope is 1. So what I'm going to do is draw a short little line that has a slope of 1. So that has about a slope of 1. Okay, and I'm just estimating. Okay, and then at the point negative 3/2 pi 0, we found out that dy dx, or the cosine x, has a slope of 0. So I'm just going to draw a line that has a slope of 0. And then negative pi 0 is the point right here. We also found out that it has a slope of 1, of negative 1. Whoops, sorry about that. So it's going to go the other way. And then negative pi over 2, 0. It's this point right here. It's going to have a slope of 0. If we kept going, if I kept those values, so now let's say I did 0, pi over 2, pi, 3/2 pi, 2 pi, we would actually see that this would look something like pi over 2 would again be 0, and then we're going to have something that looks like that. And if I ask you to find a slope at a different y value, but kept the same x value, so this time instead of saying it's going to happen at 0, let's say I said it's going to happen at negative pi over 2, 1, or negative pi over 2, 1/2. If I looked at this, if this was negative 2 pi 1 instead, notice the only thing that affected the slope's value was the x value, so I'm still going to have a slope of 1. Here, I'm still going to have a slope of 0. Here, I'm still going to have a slope of negative 1. Here, I'm still going to have a slope of 0. And now notice what we can see if I could just kept this process going for every single point that was on this chart. you're going to get something that looks like this picture down here. Notice we had these one. This was my first one that we just did. So notice we had that, and notice all of these points were just the basic points. And then if you'll look right here, I'm just going to look at this middle function right here. Notice what's happening when we connect all of the slope fields. They end up making a picture of what our solution is going to look like. So if you remember, we had dy dx is equal to the cosine of x. If we did separation of variables to solve this one, I'd get dy equals cosine of x dx, and then we take the integral of both sides, so I get y equals the integral of cosine x is sine x plus c. And now notice, I see the sine curve right in this problem. This one would actually be, our c would be 0. If we had this be y equals sine of x plus 1, this would be the solution right here. So notice we've got all sorts of sine curves. What's making a difference is what our plus c is. So if it was plus 2, my solution would be up here. So again, slope fields, what they are doing is just giving us a visual picture of what my solution is going to look like when I'm done. And I think that's all I want to say about it. Nope. Okay. Tips for drawing a slope field. The problem asks you to draw a slope field, so you're just going to draw those mini slopes. And again, when you put them all together, it makes a picture of what your answer is going to look like. The first thing that I like to do is look for 0 slopes. So is there any place where the derivative or the slope is going to equal 0? So like if I had dy dx is equal to x plus 2, I would probably look here, where would my answer end up equaling 0? When would the slope equal 0? On this case, it would be at x equals negative 2. So that's going to help me like do so everywhere where x equals negative 2, there's going to be a slope of 0. Okay, the next thing that I like looking for is to determine if the slopes are the same horizontally and vertically, right? If there's only an x in the problem, like there was right here, we are going to have vertical 0 slopes. Okay, and then if there's only a y in the equation, we're going to end up having, if I was going across this, I drew the picture kind of sideways, but we would only have slopes that are 0 going across, right? And the last thing, pick a few spots or points. So we're going to pick some x, y values if there aren't just x's or just y's, and then find the slopes one at a time. So when you do that, just like I did on the exploration, I just picked a few points. If we continue doing that for several different points, we would be able to find the slope fields. Right, some pros and cons of doing this, instead of solving a differential equation, of just drawing the slope fields and looking for the solution that way. A pro would be that it's pretty easy because all you're doing is just plugging in numbers, but the con would be that it takes up a lot of time. It takes up a lot of time. I must have my board crooked because I do, because I'm not drawing straight. Sorry about that. So hopefully now through the exploration you're just able to see a little bit what a slope field does and how it is related to a differential equation.